Devitt Machinery Company worked with Ingersoll this summer on the slaughter at Siemens Energy in North Carolina. I'm Drew Devitt, and I'd like to review with you how the capacities and experiences of Devitt Machinery Company can help you to draw significant new source of revenue from your installed base of machines. One of the beauties is that these services are completed in the field, so they have a high value for the customer and a low cost because of the short service visits that Devitt Machinery can enable. These services include in-place machining of worn bedways. By example, I would point to GM Mansfield, where scoring in the bedways of a large Ingersoll prevented the table from generating hydrostatic pressure. We were able to remachine over 100 feet of bedway in place without removal of the base fabrications, achieving a comparable surface finish and precision to Ingersoll original machining work. This machine was a steel fabricated base, and we were able to use machined surfaces on the bedway as references to guide a temporary milling system, completing the machining in 7 days. The hydrostatic bearing surfaces on the bottom of the table were recast with Mowgli's, resulting in perfect bearing and a perfect matching between the two table segments in under 4 working days. This represents a very significant problem for the customer that was solved in less than 2 weeks' time, maintaining a very high degree of precision. We have employed this process on all Ingersoll bed profiles, including tubular weigh machines. This process applies to horizontal boring mills, vertical boring mill bedways, as well as planer mills. Number 2, the refitting of rams into saddles, and saddles to crossrails, and crossrails to columns. Ingersolls seldom have positive sides in their saddles or crossrails, which means that there can be 20 or more gibs per axis of travel. Devitt Machinery has unique and proven processes for fitting the existing gibs flat against their back in the saddle, and then molding the bearing surfaces on all the gibs in the saddle at exactly the correct position and at one time. This eliminates the scraper's nightmare of fitting 20 separate gibs and provides full adjustment and perfect bearing contact in a short procedure. Number 3, large quill bores and rams in large horizontal boring machines. The boring of a 22-inch diameter quill 40 inches into a large Ingersoll headstock and without removing the spline drive is no simple matter. Very few machine tool shops are capable of completing this properly. The solution is to regrind or return the quill, removing all wear and scoring in the quill. The stock removed is then built up in the bore with a low friction molding process, creating a perfectly fit bore for the reground quill in the headstock with very precise alignment. Number 4, rebuilding of large bronze or Babbitt lined elevating and crossrail screws. There are hundreds of screw nut assemblies where owners of the machine think their only option is to refit with a ball screw and ball nut. This is a huge cost, and often they have waited to the point where they don't have time to wait for such a large custom ball screw to be made. By rechasing or regrinding the screw threads and replacing the Babbitt or coating the old bronze threads in the nut body with Mowgli's low friction material, the old screw and nut housing may be reused and backlash of less than 1/1000th of an inch achieved. This is dramatically lower cost and a faster option than they are likely to be aware of. It is common on Ingersolls to have multiple elevating screws, and each screw may have multiple nuts. The molding process allows for perfect parallelism and center positions of the screws relative to the nut locations on the headstock or the saddle, and perfect bearing on both nuts on the screw. Number 5. The freeing of sticky tables or saddles exhibiting stick slip or vibrations during their translation. When working on large expensive turbine components, stick slip or work table jitter can result in very expensive machining errors on the part. By recoating cast iron or phenolic bearing surfaces on the bottoms of tables or saddles with Mowgli's low friction bearing material and or adding pressure lubrication systems, the table travels on large Ingersoll machines can be dramatically improved. Please note that a large Ingersoll table system was rebuilt at De Laval Turbines, where the table that was 55 feet long and 25 feet across in 7 segments, weighing a total of 200 tons, was recast with perfect table segment alignment, including the positive reference surfaces on the table. A similar operation was also recently completed on the slaughter table at Siemens Energy. Number 6. The recasting of hydrostatic worm racks. This was also recently completed for the slaughter at Siemens Energy. Although this was completed under less than ideal conditions, it may be wise in the future to identify other customers who may have potential problems with their worm racks, for instance, Merrill Tool, where you could get them to order a replacement set of racks, then regrind the worm that you have and remold the set of racks that you also currently have so that they could be replaced on the table during a scheduled shutdown there. I believe we recast the racks at Siemens for less than a new set of racks would have cost, and certainly in a much shorter period of time. Much of the learning curve has been completed, and a better job could be done on the next set of racks, which are currently in your possession. Thank you for considering the processes and procedures that Devitt Machinery could employ for Ingersoll.